about deductive reasoning, okay? And that it's going to be, what have you been studying up till now? What kind of reasoning? Okay? Right, inductive, good. Inductive reasoning, that's the one where you actually see or experience a pattern and then project what's going to happen from there. Okay? Well, deductive reasoning is different. Deductive reasoning is when you use logic or facts or definitions or something you've seen that you know is a fact, like in a book, to make a conjecture. Okay? We're still making conjectures. We're still going to have an if-then statement. But instead of being that conjecture being based on experience, like seeing a pattern, that conjecture is going to be based on logic or proof or some kind of a fact or definition. Okay? So, like, here's my example. The student handbook at the Snooty Patootie Prep School requires that students wear a school uniform while at school. Okay? Based on that, my conjecture is if we visit Snooty Patootie Prep and see one of their students, then they will be wearing a uniform. Okay? So my conjecture isn't changed. We still have a hypothesis. We still have a conclusion. Okay? But it's not based on seeing. It's not saying, oh, look, out in the hall, there's 4 kids from the Snooty Patootie Prep School. They're wearing uniforms. So I'm going to guess that they wear uniforms at school. It's not that way. I read it in a book. I read the fact in a book. That's what makes it deductive instead of inductive. Does that make sense to everybody? Yeah? Can you hear? Can you articulate that for us? Can you say it in your own words? Right, and what's the difference between inductive and deductive? Say it really loud so the microphone can hear you.
Where they go and what they wear.
Okay, and how's that different than? Does someone have a clear way of describing it? Feel like you have a good way of helping the class? What's the difference between inductive and deductive? Yeah, John?
Inductive is you going off a hunch, and deductive is a detective, you're getting facts and info.
Okay, and it's a little bit more than a hunch. It's something you saw. Okay, it's a pattern you noticed, like you physically had an experience with. Okay, so you're right. Inductive is what you physically had an experience with, and now you're going to make an assumption based on that. Whereas deductive, like you said, it's based on facts and maybe something written in a book or logic. Okay? So the way I personally divide it in my head, I think of inductive is like the Mythbusters. They actually get their hands dirty and try stuff, right? They never say that a myth is busted unless they've actually tried it and it works. Whereas deductive is more like Sherlock Holmes. He just thought of things logically and used facts to come up with his assumption. Okay? So that's what we're going to do is we're going to read these and try to place them under deductive or inductive. Okay? So the first one, the Great Wall of China is the only man-made object visible from the moon. The Great Wall is barely visible in a satellite photo from 180 miles above the Earth, and the moon is 237,000 miles above the Earth. So first of all, is that true then, that you can see the Great Wall from the moon? No, can't. But do you know that it can't because of inductive or deductive reasoning? Is it based on facts or based on just your experience of being on the moon and not being able to see the Great Wall? It's deductive. It's based on facts. If it were inductive, you would literally have to have been on the moon to check it out. How many people here have been on the moon? Yeah, so it has to be up there. So we have to. So it has to be deductive. Okay? So the next one. You can balance an egg on its end only during the spring equinox. I balanced an egg on its end July 19th, September 21st, and December 19th. Inductive, why? Yeah, because you tried it. You're basing it on something you did. Good. Okay? The Ravens are going to the finals. If a team wins 10 games, they play in the finals. The Ravens won 10 games. So is that conjecture based on inductive or deductive? Deductive. Deductive. Good. Based on facts. Just if you win 10 games, you get to go to the finals. They won 10 games. All right, and the last one, you can float into the air by tying helium balloons to a lawn chair. Jamie floated in a lawn chair up to the ceiling of an airplane hangar using helium balloons. Inductive, that he actually did it. And actually, isn't that Jamie? Yes, he did it. Okay, does that make sense? Inductive, deductive, you see the difference? Okay, the rest of this chapter, we're going to be focusing on deductive reasoning, not inductive anymore. All right, and the best example of deductive reasoning is called using the law of syllogism. Okay, big word, but it's pretty easy. Okay? Syllogism, the law of syllogism says if you put a bunch of facts in a row and they all line up and there's no breaks in the chain, then you can draw a conclusion from the first and last thing. So let's do an example. So I always think of it like slides on a movie, like the different little blocks of a movie, because it all has to follow exactly one following the other. So my example is, if a power line goes down, power to the house will be cut. If power to the house is cut, the refrigerator won't run. If the refrigerator won't run, the food won't stay cold. If the food doesn't stay cold, it will spoil. Okay? So do you notice something about the conclusion of this one and the hypothesis of this one? First of all, what is the conclusion of this one? Sophia, what's the conclusion of if a power line goes down, then the power to the house will be cut. What's the hypothesis of this one, Joseph? Right. Exactly. If the power to the house is cut. So what's the connection between the conclusion here and the hypothesis here? Rebecca, what's the connection? She said the conclusion here was the power to the house will be cut, and Joseph said the hypothesis is if the power to the house is cut. So do you notice anything about those two? Okay, it's true, but isn't that if you weren't thinking about the actual events, if you're just thinking about conclusion and hypothesis, what can you tell me about the conclusion of this one and the hypothesis of this one? That makes sense. They're exactly the same. And does that always work? So this one, the conclusion is the refrigerator won't run, and the hypothesis of the next one is if the refrigerator won't run. The same again, right? And the conclusion for this one is the food won't stay cold. The hypothesis over here is if the food won't stay cold. It matches again, right? And then finally, the food will spoil. And that's what we use in the law of syllogism. If every single link in the chain is connected, so if the conclusion of this one is always the hypothesis, conclusion, hypothesis, conclusion, hypothesis, if they never break, if they always work so that the conclusion of the last one is the hypothesis of the next one, then you're allowed, the law of syllogism says, you're allowed to skip all the middle parts and just go from the beginning. If a power line goes down, you're allowed to conclude the end. The food will spoil. You're allowed to skip all the other stuff and make that conjecture, and that conjecture will be true. So after you get all your statements in a row in the right order, then you're allowed to conclude that the hypothesis of the first statement and the conclusion of the last one. So my final conclusion would be if a power line is cut, then the food will spoil. My writing is just terrible there. Then the food will spoil. Does that make sense? The very first thing and the very last thing. Okay? And in the example, like, you know, the symbols we used over here, same thing. If P, then Q. If Q, then R. If R, then S. If S, then T means if P, then T. Does that make sense? Let's do an example just to make sure. Okay. We're given that if the measure of angle A is less than 90 degrees, then angle A is acute. If angle A is acute, then it's not a right angle. So our conclusion could be first P and then R. But let's work through that. So what's if P then Q? From this example, what is P then Q? I'm sorry, from this one.
Oh, then if measure A equals 90 or is less than 90 degrees, then measure A is acute.
Exactly. If the measure of angle A is less than 90, then angle A is acute. Okay, that's if P then Q. Do you know what's if Q then R?
If angle A is Q, then it's not right angle.
Right. If angle A is acute, then it's not a right angle. Okay? So the law of syllogism says I'm allowed to go, if these are true, if these are connected and they aren't broken, the chain is strong, then I'm allowed to skip all the middle parts and just go from if P, then R. So James, what would that be? What's P? Someone up closer then, I guess. What would P be? Can you help them out? Read it.
90.
The whole sentence. If
Measure A is less than 90.
right. That's P, right? So stop there. If a measure of angle A is less than 90, right? Because that was the first statement, the first P. And what's R? What's the last conclusion? Right. Then it's not a right angle. Okay? Now, there's one little wrinkle in this, and that is it has to be a complete chain. It has to be the conclusion of the last sentence is the hypothesis of the next sentence. It has to go in that order. So sometimes you have to stop and put them in order first. Okay? Like for instance, in this one, if an animal is a mammal, then it has hair. If an animal is a dog, then it's a mammal. Is that in the right order? Why not? How can you tell? Vicky, how can you tell?
Because, like,
If it were in the right order, what would have to be here? It says this is if P then Q, right?
yeah.
And this would have to be if Q then R. So what would this have to be? Right. And what would it have to say in this example? Then.
Do you see that in this first sentence here, this is your P, right? If an animal is a mammal, that would be your P. Can I write on this?
Yeah, of course.
Okay, so this is your P right here.
It did.
You did. This is your P. Okay, right here. And this would be your Q. Do you see that? So if it were to make sense, then the Q would be here. Is this Q? Can I call this Q? Is this the exact same as this? No. So how would I would have to flip-flop these two sentences, right?
Since there's only two of them, it's easy to figure out what the right order should be.
So if I were to start with the second sentence, sorry, I just erased that. So here, this is my P, and this is my Q. Here, do you see that? So if this is my Q is now up here. Do you see that this is the same here? I can call this Q. Are you following me? Okay. Let me try to explain it again. Anybody flip-flop these sentences? These sentences are just out of order.
Are they separate? No, they're all one. Sorry.
So I have to decide which sentence comes first. Should this sentence come first? See how the end of this sentence right here, it is a mammal, is the start of this sentence up here? Do you see that? So I just have to flip-flop these two sentences to say, if it is a dog, then it is a mammal. If it is a mammal, then it has hair. Do you understand that? Okay, that's all it's saying.
Okay, so in this example, what would be if P then Q? Michaela, what would be if P then Q? Right, good. You have to start with, if it's a dog, then it's a mammal. And then what would be if Q, then R, Nikki? Yeah, so what's Q? Good, exactly. If it's a mammal, then it has hair. So what can we conclude then? Sarah? Is a dog? Okay, that's P, right? If it's a dog. But what's R? Nope.
Mickey, what's the
Yeah, right? Because if P, then Q. If Q, then R.
see how it kind of snakes around, like it kind of follows in a pattern?
Does that make sense? So if P, then R would be, if it's a dog, then it has hair. Does that make sense? Okay, so we're going to practice that with a little activity.